Another simple and effective way to assess the model's performance is to split your data set into training and test data. Okay, so in this illustration, given a full data set, the first step is to arrange the data into features and your target variables. Okay, then the next thing is to determine how you want to split. Most times you can use this approach. You can do a 90-10, meaning here this is the training and this is the test, right? So meaning 10% of your full data set is test data. So it could be 80-20, 70-30 split, or 60-40, meaning 60% will be training data and 40% will be your target data. Okay, so once you do that, of course, the way you select that, do random sampling, right? Again, now you have your X train and Y train. So for example, if we pick this, for example, that means 80% of your data is training data, and 80% and 80% of your target is actually Y train. Okay, then your test data will be the remaining 20%. Okay, 20% of your training data and 20% of your target data. Okay. Now, sometimes we refer to this X as independent variables, or we can call this input variables or predictive variables. In this case, we are using features, all right? And then your Y trend, sometimes we also refer to this as your Y in here will be output variables, dependent. So this would be dependent variables, okay, or outcome variable or response variables. All these are different names you'll come across that could be used interchangeably. So once you have that, then you select your classifier. This could be maybe decision tree or maybe logistic regression, right? And use this algorithm and you train it on your model, right? For both X train, and you test it on your Y train, or rather you test it on your training data, which contains both X train and Y train. Then you use this 20% of your data for testing. Okay, now let's look at exactly here what happens, right? So data splitting here just refers to the process of dividing the data set, right, into multiple subsets. These subsets could be training set, validation set, or testing set. Now, the training set here, most times we use this to design our model, right? This could be the largest subset, as we've already seen here. When I go back here, you can see this is the large subset. Okay. Again, validation here, we use this to validate the model, right? So we use this to refine the model in order to prevent overfitting. Okay. And validation also is used to help fine-tune the model parameters. Okay. Again, this just not only helps with mitigating overfitting, but also tries to improve the performance, the accuracy of our model. And lastly, we have the test data, right? So again, we use this to test our model. That's why it's called testing set. Okay, we evaluate the performance of our model on previously unseen data, right? This will just help our model to, improve on generalization performance, right? And also to compare on different models. Okay. So again, overfitting here basically is just a term that's used to, occurs when there's too complex of a model, right? Or your data, your model trains too well on your training data, leading to poor performance on unseen data. Okay. Now let's look at an example here. All right. So here, let's say you have your available data. So let's say, for example, here, let's assume that we have a data set, right? So let's say we're having a data set that has 1,000 customers. Now we want to split this data set into training, validation, and testing, right? So in this case, let's say we want to use 15% for our validation and 15% for testing set. So when we do that, we'll generate a table like this, right? So our training data will contain 700 training samples. These are customer instances, right? We call these training examples, right? These are just the rows, the full examples. right? Training examples. And then validation here will contain 150 customers and then also testing 150 customers. So again, you can see here, training, we have 700, validation 150, and testing, we have 150. So you can see here for a training customer, we've split this to be our training model, right? This model will use this data to learn the relationship between the predictors and the target variable. In validation here, we have 150 customers or training examples, right? Well, that means that's 15% of our full data set, right? Again, we use this to validate the model, right? So the model will use this data to tune its hyperparameters and ensure that it's not overfitting, okay? And then lastly here, testing, we also have 150 customers. That's just 15% of our data set, right? Now, we use this as is held out from the model, okay, during the development process. And we use this to evaluate the performance of the model. So this testing set, okay, this testing set is used to provide a final assessment of our model, okay? How well does our model generalize on unseen data, okay? Or we can use this to compare different models, okay? Now, in this example, we've seen how to split the data into 3 subsets, that is training, validation, and testing set, right? Again, just keep in mind that overfitting might be a challenge here. So the choice of the data split is dependent on the size of the data set and the requirements of the problem, okay? Again, it's very good. It's important to have a good understanding about the trade-off between the size of the data, right, and the model's performance, okay? So in Python implementation, right, what Python does here, so I just generated this code. You can see we import this function called train test split. Okay, so from this library called sklearn, mostly used for ML, right? So we want to import this module, right, model selection, that help us to import this train test function, test split. And then also, because this is a classification problem, we import this classifier called logistic regression. Then also import all these other different functions to evaluate the confusion matrix and assess the performance of the model. We load the data set using the pandas read underscore CSV. And then we use this function here. As you can see, so this will be so we want to drop our the class. So this will be a X and this will be a Y. Okay. So essentially this will be split based on 0.2. That means 80% to 20%. Okay. So meaning our training data here will be 80% and our test data will be 20%, the remaining. Okay. So this will be apportioned to, so our X train here will be 80%, right? And our Y train here will also be 80%. Our X test here will be the remaining 0.2, right? And this will be remaining 0.2. Okay. Now in our implementation, we just load these 2 libraries, tidy models. It comes with a read underscore CSV. It also includes a package or library called readr that allows us to read our data set. Okay. And then we also use this function initial underscore split, right? We pass our data frame here, PIMA in the data set, right? And then we use this argument or parameter here, prop, meaning the proportion we want to split, 80 to 20% split. Again, we save it as this variable. So when we print this object now, you can see that we've split our data set into 614 for training set, and then 154 training samples for the test set. And you can see our total training sample, our full data set. This is the full data set, contains 768 and split into 80, 20%. Weka implementation, in fact, let's just go live here. You can actually, for example, here, we can choose a function, logistic regression, okay? And then here you have an option to use the training set, the entire training set. But if you're gonna use the split, so we can choose here percentage split. So let's say we want to do a 60-40, right? So I'll just put there 60% and the remaining will be used for, for evaluating the performance. So we wanna train our data set here. In our case, our data set here is just the iris data set. So you click on start and you can see we've just performed logistic regression on our training data at 60%. Okay. Now in summary here, so in summary, in conclusion, we can say that this train test split is widely used technique for splitting data in machine learning. Of course, the process involves, dividing the available or the full data set into two separate, or rather three separate sets: the training set, sometimes validation, and test set. Okay. Again, we use the train set to train our model, right? And the test set, we use that to evaluate the performance of our model, right? So again, the ratio, the trend test split is simple and effective technique, right? So this technique is actually simple and very effective in the sense that we can use that to quickly provide a check of the model's ability to generalize to new unseen data. Okay. However, it's important to also account for overfitting issues, right? Sometimes, we don't need to, you don't need to rely too much on the performance, right? To address this, we can use cross-validation techniques, right? Just to ensure we provide a more robust estimate of the model's performance. Okay, this will ensure that we generalize well on the new data. Okay, again here, the ratio of the split often is determined by the size of the data, right? With larger data set, maybe you require smaller portions. So assuming you have 10,000 training sample, right? So maybe if you do 20%, that's just good enough, or 10%, 90% for training, that will be 9,000 samples and 1,000 for test. So again, the ratio there, it depends with how large your data set is, right? Okay, and that's it as far as data splitting is concerned.